what's going to happen with finding vertical stretches and compressions in chapter 3, you're going to learn a way that'll work that doesn't just rely on your intuitive understanding of how the polynomials work. Quadratics are pretty easy because this you can always do. These you can always do the way I'm going to show you right now. But we'll get that a little more sophisticated in a little bit, in a couple of weeks. So right now I'm just graphing this function here. So this is kind of like anytime I have a x squared function. If you go either side of, so here's the vertex. I know this is a different vertex, but it works the same for x squared. If I'm going over 1 and I square it, I go up 1. If I go left 1, -1, and I square it, I go up to +1. So this doesn't have a vertical compression or vertical stretch because it's just like 1x squared. See, I can go over 2, and if I square the 2, I should get 4. 1, 2, 3, 4, and I do. If I go over 3, I'm going to go up 9. So there's 2, here's 5, here's 2 more. So that's 9. Okay, so 3. So that's just like the regular old x squared. And the same thing you've got in the negative. You know, -2 ends up 4, and -3 from the vertex ends up 9, and so on and so forth. Okay, so keep that in mind for the base function, the parent toolkit function, if you want. Now I've graphed something out using the language of transformations. I've got a parabola that's been stretched vertically by a factor of 2. So let's see how that works. If this has just been x squared, or if this had just been the first one, I would have gone over 1, up 1, over 2, up 4, and we can see that that's not going up high enough. So if I go over 1, I go up 2 to get to the graph. So I know that and if I go over 2, it's got to go up 8 to get there. If I go over 3, I've got to go up 9 times 2 is 18. I'd have to go up here to 18. Of course, that's off the graph. So that would tell me that this has been stretched by a factor of 2. Okay, and that's the stretch factor. That's the leading coefficient, if you want. And then for this one, this has using the language of transformations, this has a vertical compression because it's not growing as fast. If I can spell compression by a factor of 1/2. Or you could say compression by a factor of 2. That would work too. And just see how that works. See, if I go over 1 from the vertex, I'm supposed to be going up 1 if nothing's happening, and it's not. So to me, it kind of eyeballs it. It goes up a half, kind of. We can see that. But if we go over 2, it's supposed to go up 4, and it's only going up 2. So you see that's half of what it should be. So that tells me that the leading coefficient there should be 1/2. Okay, so that's how you can do it just by looking at the graph and thinking about stretches and compressions. Okay, hopefully this helps. Maybe you already understood this. I thought I'd record the video.